In lesson 12.5, which is problem solving with trigonometry, I just wanted to show you really an example of a problem that's pretty complicated, not one that you're going to actually have to do in our course or anything like that, but just kind of the epitome of how you put the law of sines and law of cosines together. So in this particular diagram down below on the left here, Johnny is in a stream that's running north to south at 3 kilometers per hour, and he's rowing northeast at a rate of 4.5 kilometers per hour. At what speed is he actually traveling? Now, if we sketch these speeds in blue and create a parallelogram, you can see that we create the resulting vector in the true direction of his travel. So one of the things that you'll notice is that, let's see, what's the best way to describe it? So I have the stream, if I use, for example, the red color. So here's my stream, if I highlight what's going on here in north to south at 3. And if I were to highlight that for you, this red vector is what they're talking about. And then I could also talk about, of course, he's rowing northeast at 4.5. And if you look at him rowing, this is him at 4.5 in the blue. And what's happening as a result is, what does he really travel at? So his canoe is going one way and the water is going the other way. And in the end, what really ends up happening is what they're talking about. And that would be in the green here, if I were to draw it in green, is what he's actually doing. And if I highlight what's happening, is we're really looking for his vector in the true direction of his travel. That's kind of the goal. And so then we pick an angle for the parallelogram at random, 45 degrees I chose, and we create two different triangles. And using the law of cosines, which we talked about earlier in the yellow here that's highlighted, we could figure out how big the dB is, which is 3.2. And then also the direction of travel we can do using the law of sines then, if we wanted to, and the law of sines, if we use the law of sines, we could figure out our angle is 42 degrees. And so what I wanted you just to understand is that really, when you look at real world applications of what's going on, law of sines and law of cosines can be used to find out complex the answers to complex questions. And this is just one example of how you would do that. And so I just wanted you to kind of see one of those examples. You're not going to have one anywhere near this complicated on your quiz or your test, but I thought it'd be a kind of a fun final way to end the course, just to show you the advanced top of things that you would be capable of if you wished to pursue something like that after this course and figure out problems like this. It's been a pleasure having you. We look forward to talking to you a little bit later. Bye.